Welcome to the DIY Honda Garage channel. DTC P2237 refers to an issue with the air-fuel ratio A4 sensor 1 in the Honda Civic 2022 and newer models. The specific fault indicates that there is a high voltage detected in the input circuit of the A4 sensor. The A4 sensor plays a crucial role in monitoring the air-fuel mixture in your vehicle's engine. It communicates with the Powertrain Control Module, PCM, to ensure that the engine is running efficiently and within the correct parameters. The sensor is typically located in the exhaust manifold, close to the engine, where it can accurately measure the exhaust gases after combustion. When the PCM detects an abnormality in the sensor's IP terminal voltage, it triggers the DTC and stores it in the vehicle's computer system for later retrieval during diagnostics. The DTC P2237 is triggered when a high voltage anomaly occurs in the input circuit of the AF sensor, specifically known as sensor 1. This sensor is vital for assessing the balance of air and fuel in the combustion chamber, hence contributing to optimal engine performance and emissions control. It is strategically located near the exhaust manifold to effectively measure the exhaust gases, allowing the PCM to make real-time adjustments to fuel injection and air intake. When the input voltage from the AF sensor exceeds normal operating limits, the PCM registers this fault and sets the DTC. Notably, a consistent high voltage reading could indicate an internal defect in the sensor or issues within the electrical circuit leading to the PCM. Several potential causes can trigger the DTC P2237 fault code. Firstly, there may be an open circuit in the wiring connected to the A fault sensor, which can prevent proper communication between the sensor and the PCM. Secondly, the A fault sensor itself could be malfunctioning, resulting in incorrect voltage readings being sent to the PCM. It is important to assess whether the sensor is functioning correctly or if it has failed. Lastly, a faulty PCM could also be the source of the error, though this is less common. It is essential to systematically examine each of these components, ensuring all connections are secure and free from corrosion or damage before concluding the investigation. Drivers may experience several symptoms associated with the DTC P2237 error code. Primarily, the check engine light will illuminate, signaling that there is an issue requiring attention. Additionally, because the AF sensor influences the engine's air-fuel mixture, drivers may notice poor fuel efficiency, leading to unexpected increases in fuel consumption. This can be particularly concerning in today's economy, as it results in unnecessary expenses. Furthermore, an improperly functioning AF sensor can lead to increased emissions, which may cause the vehicle to fail emissions testing due to deviations from environmental standards. Awareness of these symptoms can prompt timely diagnostics and repairs, preventing further complications. The first step in troubleshooting DTC P2237 involves starting the engine and holding the engine speed at 3,000 RPM without load. This means that if you are driving a CVT, continuously variable transmission vehicle, it should be in park or neutral. And similarly, if driving a manual transmission, it should also be in neutral. By holding the engine speed at this RPM, you can allow the system to reach a stable operating condition where sensors and the PCM can effectively communicate. The process continues until the radiator fan activates, signaling that the engine has reached an appropriate temperature. After this, the vehicle should be allowed to return to idle, setting the stage for further diagnostics related to the AF sensor's performance. In the second step, the focus is on ensuring the integrity of connections involved in the AF sensor's function. First, the AF sensor's 6P connector must be disconnected from the wiring harness. Following this, The PCM connector, identified as connector E with 80 pins, is also disconnected. This prepares the components for inspection. At this point, an inspection of the input IP open wire is necessary, which involves examining the female terminals of both the AF sensor and PCM connectors. The goal is to verify the connectivity and determine if there are any faults present within the wiring. A normal condition would read less than 1 ohm of resistance when checking for continuity, confirming that the circuit is intact. The third troubleshooting step is critical for ascertaining whether the AF sensor itself is functioning. After confirming that all connections are secure, begin by conducting the confirmation procedure to enable critical checks. With the AF sensor still disconnected, the ignition must be turned on to IG mode. This allows for voltage testing without starting the engine. The objective is to measure the output voltage of the AF sensor. During this test, a normal reading would show approximately 0.2 volts or higher. If the voltage is significantly lower or entirely absent, it indicates that the AF sensor is likely defective and warrants replacement or further investigation. After completing the inspections and potential repair of the AF sensor or associated components, reconnect the AF sensor and PCM connectors securely. Once everything is back in place, start the engine again to observe its performance. Pay close attention to the operation of the engine and any indicators on the dashboard, particularly the check engine light. Next, utilize a diagnostic tool to check for any remaining or new diagnostic trouble codes, DTCs. If the DTC P2237 is still present, it indicates further issues with either the sensor or the circuit. Conversely, if the code clears, it confirms that the repair or adjustment has resolved the issue, validating the troubleshooting process. Preventive maintenance is crucial in preventing future occurrences of DTC P2237. Conduct regular inspections of the AF sensor as part of a comprehensive vehicle maintenance routine, ensuring that it is clean and functioning correctly. Inspect the wiring harness and connectors for any signs of wear, corrosion, or abrasion, which can lead to poor connections or shorts. Additionally, considering routine diagnostics can help catch potential issues early, allowing for timely fixes before they escalate. By staying on top of these aspects, drivers can significantly extend the life of their vehicle's emission control system and maintain optimal engine performance. In summary, understanding DTC P2237 involves recognizing its implications for your vehicle and the vital role of the AF sensor in maintaining engine efficiency and compliance. Regular monitoring of the AF sensor and related circuitry can prevent more consequential issues from arising. Addressing wiring problems and ensuring robust connections are critical elements in effective troubleshooting and repair. Furthermore, conducting timely diagnostics can reveal underlying problems before they compromise vehicle performance. Overall, proactive measures not only enhance the vehicle's longevity, but also contribute to a cleaner environment by ensuring optimal emissions control. Please like and subscribe to the channel. See you next time.